These are Algebra 2A notes on complex numbers, which is section 4.8. Before we do that, I want to review briefly on how to reduce roots. So reducing roots, let's start with something like square root of 49. So square root of 49, 49 is a perfect square. A perfect square because 7 times 7 gives us 49. Therefore, the square root of 49 comes out even. The square root of 49 is just 7. Easy enough. Sometimes, though, we get a root that does not come out even, like square root of 18. Square root of 18, 18 is not a perfect square. There's not an integer that if I multiply it by itself is going to give me 18. So what we want to do is we want to write this in its simplest form. And to do that, we want to find a factor of 18 that is a perfect square. Now remember, perfect squares would be 1 squared, or 1, 2 squared, which is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, 6 squared is 36, and so on. There's a bunch more. So what we're trying to do is we're trying to find one of these that goes into 18, that is a factor of 18. 9 times 2 gives me 18. So I'm going to rewrite 18 as the square root of 9 times the square root of 2. 9 times 2 is 18. And again, I'm using 9 and 2 instead of like 6 and 3, because 6 is not a perfect square, 3 is not a perfect square. I need one of them to be a perfect square. The square root of 9 is 3. Square root of 2 doesn't come out even, so I just get 3 root 2. Let's try another one. Let's go square root of 75. Square root of 75. So 36 is not a factor of 75. If you're not sure, you can do 75 divided by 36. It does not come out even. 75 divided by 25 does come out even. So 25 goes into 75. It is 25 times 3. 25 times 3 gives me 75. 25 is a perfect square. Again, I'm using 25 and 3 because 25 is a perfect square. I would not use 15 and 5. 15 times 5 gives me 75, but neither of those numbers are perfect squares. And then the square root of 25 is 5. I get 5 root 3. So that will lead us into today's notes, which are in section 4.8. It is titled Complex Numbers. And we want to start by examining the square root of negative 9. The square root of negative 9. Notice if we try to think of a number times itself that gives us negative 9, we're going to struggle to come up with one. Because 3 times 3 is 9, but negative 3 times negative 3 squared, is also positive 9. So this can't be negative 9. Notice if we're talking about real numbers, there's nothing we can come up with that when multiplied by itself gives me negative 9. Notice you can check it on your graphing calculator. If we type in the square root of negative 9, it gives me an error and says it's not a real answer. Which is true. The square root of negative 9, we say it's undefined, but the problem is the square root of negative 16 is also undefined, but these are different things. So we need some way to tell the difference between the two of these, even though neither one of them are defined on the real number set. So what we do is we define what we call the imaginary number I as the square root of negative 1. I is the square root of negative 1. And now I can simplify the square root of negative 9. I can rewrite it as the square root of 9 times the square root of negative 1. Just like I rewrote 75 as square root of 25 times square root of 3. And now the square root of 9 is 3, and the square root of negative 1 we just defined as I. Square root of negative 9 we say is 3i. We can do the same thing with the square root of 16. Square root of 16 is 4, and the square root of negative 1 is I. So now we have square root of 16 and square root of negative 9. Even though they're both undefined, we can tell them apart when we simplify them using this imaginary number I. We can do one that doesn't come out even as well. Let's do the square root of negative 24. So the square root of negative 24. The first thing I'm going to do is do 24 times negative 1, like we did here. The problem is the square root of 24 doesn't come out even. So I need to simplify it the same way I simplified these. So we are looking for a factor of 24 that's a perfect square. Now, 3 times 8 is 24, but 3 and 8 are not perfect squares. 4 times 6, 4 is a perfect square. So I'm going to go 4, square root of 4, square root of 6, square root of negative 1. And then the square root of 4 is 2. The square root of negative 1 is I. And this root 6 doesn't come out even. We always write the part that doesn't come out even at the end. So I can multiply in any order I want. So I wrote the square root of 4 here, and then the square root of negative 1 is that I. And then here's my square root of 6 right there. So we can reduce roots using this imaginary number I. The next thing we want to do is add or subtract complex numbers. Probably should call this example 1. This will be example 2. We're going to do 5 minus 3i minus 7 minus 2i. So we are going to subtract two complex numbers. Remember, when I add or subtract, I am not going to FOIL here. I see a lot of students want to FOIL when you see two things in parentheses. It's got a minus sign in between. So the first thing we need to do is we need to distribute this minus sign. I'm going to distribute this 7, or distribute this minus sign to the 7 and to the minus 2i. So here I've got 5 minus 3i, and I've got minus 7 minus negative 2i, minus a negative, minus, that changes to plus. And now all I need to do is combine up my like terms. 5 and negative 7 are like terms. I can combine those two. Those make negative 2. And then negative 3i plus 2i gives me minus 1i. So we can subtract. If I'm adding, if that's a plus sign, you just distribute your plus. We were also going to learn how to multiply these. We said earlier that I is equal to the square root of negative 1. I can square both sides, I squared. If I square this side, a squared and a square root cancel. So I squared equals negative 1. So in example 3, we are going to multiply. Let's go ahead and just multiply these two. 5 minus 3i times 7 minus 2i. Well, if I'm multiplying two quantities, that is when I do my FOIL. I do 5 times 7. 5 times 7 is 35. And then I do 5 times negative 2i. That's minus 10i. I did the first one times each of those. Now I do the second one times each of these. Negative 3i times 7 is minus 21i. And negative 3i times negative 2i. Negative 3 times negative 2 is positive 6. I times I is I squared. Combining my like terms, I've got like terms right here. I'm going to combine those. Negative 10i minus 21i is negative 31i. And then don't forget, I squared is negative 1. So I'm just going to replace the I squared with negative 1, and I can continue to simplify. 6 times negative 1 is minus 6. 35 minus 6 is 29, minus 31i. That is it for today's notes. If you're having questions on anything, please reach out.